The Defense Intelligence Agency provides all-source intelligence to prevent strategic surprise and to enable informed decision-making, rapid decision-making by warfighters, defense planners, and policymakers. To that end, engineers are uniquely trained academically to decompose and solve very challenging technical problems that help us answer some critical intelligence questions that support senior-level decision-making. DIA continues to be a leader in applying cutting-edge technologies in highly secure environments. Some of the things that we're working on today are obviously reducing our reliance on foreign sources of energy. We want to reduce our footprint both from a ecological standpoint, but also from a presence standpoint. I mean, if we're using fuel, if we're drawing electricity when we're doing our operations, there's some indication that we're doing something. So we look at self-reliance as being a very important technical problem to solve for our folks that are deployed around the world. Some of the other things that we're very concerned about is supply chain integrity, specifically for the defense industry, but it has application across all of our society. We're also concerned about biometrics, and I think everyone can relate to the concern regarding identity theft and the integrity of your identity online and in commerce. When you scan your ATM card, you don't want a surreptitiously in place device reading your ATM card while you're thinking you're drawing money. That's some of the criminal uses of those technologies. Obviously, we're very concerned about that for many reasons, but our examination of the problem and what our engineers are doing to research it also help to answer critical intelligence questions. But again, from a broader perspective, I think everyone in society will ultimately benefit from improved biometrics technology, providing that security on a day-to-day basis of your identity. In many instances, I think that a lot of research is initiated without consideration of the spin-offs. Again, we're trying to solve a real problem that's sitting in front of our organization. However, we are cognizant of the wider implications of the results of the research and the potential applications outside. I previously mentioned biometrics and its possible support for alleviating the risk associated with identity theft to everyone. I'm worried about identity theft just in ordering things online, and I'm sure a lot of other people are too. Some of the research that's going on now may help reduce that risk in the future. Another area that's challenging is supply chain integrity. I think I mentioned that earlier. One of the concerns is when you have counterfeit parts or components, it's the integrity of the component level that could possibly impact across the financial, transportation, and medical sectors. If there are counterfeit components installed on medical monitoring equipment, there's life safety issues associated with that. So I think a lot of the things that we're doing today to secure, for example, defense infrastructure and defense supply chains will have greater societal impact as we confront these problems in the future, especially as more and more commercial manufacturing moves offshore, so that we know that what we get back is what we think it is and will operate to the levels of reliability that we expect. But in 10 years, I think our biggest problem is going to be too much information, not being able to move it fast enough and understand what's in it. Again, ultimately to divine the capability and intent of our adversaries in order to keep this nation safe. As we look at the expansion of information technologies, the flow of information, the velocity and the sheer volumes, we are going to be challenged in the future managing not only the understanding of those masses of information, but also moving them and storing them. And again, I think the potential there is huge for additional spin-off technologies and other societal applications. I think the first thing that comes across is flexibility. In many instances, we have young engineers coming out of school as mechanical engineers or electrical engineers or civil engineers, and they're put into, and especially in the federal environment, they're engineers first, and engineers are seen as being those disciplined problem solvers. So we need an agility of the mindset to be able to use the skills they have and apply them against problem sets perhaps they haven't been academically trained for, but they have the fundamental building blocks. To that end, I think in the future what will become more important is applied mathematics and statistics to develop novel quantitative approaches to answering some of these questions. We build more sophisticated sensors. To make sense of that, we need more sophisticated algorithms. The engineers that are implementing those algorithms are going to have to understand how they work. Not necessarily develop them, that's for the science, but the engineering is the application. And I see a real need for future engineers to have that mental agility, to be able to take the building blocks of what they have and go in a different direction. I was academically trained as a mechanical engineer, and across my federal career, I've done the bulk of my work in civil engineering and chemical engineering. That's how it rolls. What was striking to me as completing my bachelor's in engineering, I graduated from the Rensselaer Polytechnic Institute in mechanical engineering, and going into the quote-unquote real world was theory was fine, practical application is everything, and learning not just the tool sets, but also where the resident knowledge lied. And one thing that I had to work on early on, and it has served me well since, is truly understanding prior art. There are very few truly new inventions in the world at any one time. It's the pace of introduction of technology is very high, but the fundamental principles upon which they're based are relatively finite. The ability to do the appropriate literature searches, understand prior art, and then see how that has progressed will lead you in the direction you need to go to solve future problems in many instances. In those areas where it does require true invention, now you are back into the basic research space, which is probably more appropriate in academia than in practical applications in the field. Engineers in the intelligence community support our silent heroes, those intelligence collectors and analysts in the intelligence community, the agencies in the field. And to that end, much of the work we do in order to protect them and to protect national security must remain in obscurity and not released in the public. We don't actively advertise for that reason the accomplishments of our teams. I work in the intelligence community, and much of our work is classified. Engineers who enter the intelligence community accept that their work will remain in obscurity, quite possibly for their entire careers. And that's something that we have to do to protect national security. We just accept that. I'm not sure I exactly accept the premise of the question from the standpoint of we look at what feats have been accomplished, for example, by the NASA Mars Curiosity entry, descent, and landing team, and what they were able to accomplish. Amazing feats of engineering I don't think needed any kind of press release. Our human capital professionals within the agency actively engage universities across the country during recruiting events, and also engage professional associations and organizations such as the Association for Engineering Education to advance opportunities within the agency. And there's always www.dia.mil for more information.